Understanding the idea of synthetic division and the remainder theorem and the zeros theorem allows us to then construct polynomials. A couple of things that we know from the previous videos. We know that C is a zero or a solution of P of X if and only if. This double F means if and only if X minus C is a factor of P of X. If we want to construct a third degree polynomial, we know it's going to have X to the third power. If we know it has these three zeros, we can convert those zeros into factors. Then this describes the end behavior to us. So what this tells us is as X goes to infinity, so as X is going along here, Y is going down. Well, that tells us that the leading coefficient has to be negative from our chart back several videos ago. And because it's odd degree, we know that the left side has to do the opposite. What this can conclude then is our general polynomial may not be the only one that exists of this form, but it's going to have these factors and it's going to have a negative leading coefficient. A second example there, if we're constructing a fourth degree polynomial with these zeros, those zeros allow us to write the factors. But in this case, it's fourth degree. It doesn't tell us what the leading coefficient, whether it's positive or negative, but it does tell us that we have an x-intercept at 15. Well, x-intercepts by definition, a y-intercept at 15, have an x value of 0, which tells us that we can plug in 0 for all the x's, which leads us to 5 times 2 times -1 times -3. We know that has to equal 15 times some leading coefficient that we don't know what it is. And this leads us to positive 30a, because a negative times a negative. And when we solve for a, we get that a is 1/2. So our polynomial in this case is 1/2 x plus 5, x plus 2, x minus 1, x minus 3.